Okay, so everyone can hear me and see my screen?
Yeah.
Cool. So the goal is that I will have all of your short answers graded by Thursday. That's probably your first question. And then this week is a pretty short sheet, so it won't be terribly long. Do people have any questions about the exam first? Okay, cool. So do people have any questions about the homework or this assignment right here that they want me to go over to start off? Cool, I'll just go straight through them. Okay, so the derivative of 4e to the 2x squared minus 4. So this guy right here is actually basically just a chain rule, how we get this. So e to the f of x, the derivative of that is going to be f prime of x, e to the f of x. So in this case, we have y prime is going to be equal to 4 times the derivative of derivative of f of x. So that's going to be just 4x times e to the 2x squared minus 4. Does that make sense to everybody? Cool. So this right here is going to be another chain rule, but a very simple chain rule because the derivative of the inside is just 1. This guy, again, simple chain rule, derivative of the inside, it's just 4. And then a product rule. So we have first times the derivative of the second plus the second times the derivative of the first. Does that make sense to everybody? Okay, so this again is just going to be this is actually going to be kind of a nested chain rule. So the derivative of the inside is going to be 2 from the 2z plus negative 2z from the derivative of the top here times e to the negative z squared. That guy all squared, or that guy times 2 from the power rule, and then the inside. Plus e to the negative z squared, and 2 to the minus, or 2 minus 1 is 1, so it's just to the single power. Does that make sense to people?
Yes.
Cool. And now do people want me to do this as a quotient rule or as a product rule?
Quotient?
Cool. So just as a reminder, the quotient rule is bottom times the derivative of the top minus top times the derivative of the bottom all over bottom squared. So in that case, we get y prime is going to be equal to the bottom, so that's e to the 2t plus 1 times the derivative of the top. So the derivative of the top, we need to do a product rule for this one, and then the 2 is going to disappear. So the product rule is going to do, so first times the derivative of the second, that's t times e to the t, because e to the t is its own derivative, plus the second times the derivative of the first, but the derivative of t is just 1. So it becomes t e to the t plus e to the t, plus minus the top times the derivative of the bottom. The 1 again is going to disappear, and we're left with 2e to the 2t. And that whole thing is over e to the 2t squared. Does that make sense to everybody?
Yes.
Good. So the world population in billions is predicted by P of t is equal to 5.8 times e to the 0.0175 t, where t is the number of years. Find the rate of change of the population in the year 2020 in this model. So here, the instantaneous, or this is saying the rate of change. It's only giving us a single point, so it's asking us for the instantaneous rate of change or the derivative. So P prime of t is going to be equal to 5.89 times 0.0175 times e to 0.0175 t. And then we're just going to plug in 20 because years after 2020 or after 2000, so 2020 is going to be the value of 20. It's just going to be equal to 5.89 times 0.0175 times e to the 0.0175 times 20. And now this, if we plug that in, apparently we get 0.14627. So this original guy is billions of people. Billions of people. We took the derivative with respect to time, so it becomes in years as our unit. Billions of people per year is my new unit. So if I'm going to interpret this in kind of more natural language, that means at 2020, the rate is increasing, or the population is increasing. At 146.27 million people per year. Does that make sense? Yay, nay?
How did you just convert that to million?
So this is in billions. So if I do 1, 2, 3 million.
Okay.
I think most people feel like it's more natural to work in whole numbers of millions as opposed to decimal points of billions. But if you had put 0.14627 billion people per year, you would have been correct still. It's just, I think, less natural for people to work with. Anything else? Cool. Okay, so this guy, there's two different ways I can go about doing this. There's kind of the slightly longer, more brute force way to do it. And then there's the slightly cleverer way that saves you a step or two, makes it easier. Do people know what the cleverer way is? Well, in either case, I'm going to start off by switching this to ln of x plus 5 to the 1/2. What would people do next? Somebody shout at me.
Chain roll.
Hmm?
The chain roll.
Okay, so the chain rule, what would the derivative of the inside get me? Yeah, Jack got the cleverer way to do it. But let's keep on doing the chain rule and then I'll go back and do the cleverer way. So the chain rule here, we would get 1/2, and now we get x to the negative 1/2, and then we would get ln of the inside. So that would be 1 over x plus 5 to the 1/2. But guess what? That's the same thing as this, so that's equal to 1/2. Oh, no, not plus, times to 1/2 times 1 over x plus 5. So that is the more brute force way to do it. It's perfectly acceptable. But instead we could have gone here and just pulled out 1/2 ln of x plus 5 using the laws of logarithms that we know. And then, that's equal. So that then goes to the derivative of that would be 1/2 over x plus 5. So this is equal, and then the derivative goes to here, which is, we get the same thing either way, but it's easier if we just manipulate the laws of logs. Sorry, did people have any questions about that? Okay. So now this guy is going to be a product rule, right? So we get first times the derivative of the second plus the second times the derivative of the first. And if we simplify this guy just a little bit, we get t plus 2t ln of t. And I'm just going to capitalize my t's so that you can tell them apart from my pluses. Does that make sense to everybody? Cool. So do people want me to do this as a product rule or as a quotient rule?
Quotient.
Okay, cool. So again, quotient is bottom times derivative of the top plus the top, minus the top times the derivative of the bottom. And then that is all over the bottom squared. So in that case, we get ln of x times the derivative of the top is just e to the x still, minus e to the x, because that's the top, times the derivative of the bottom. So that's 1 over x. And then that would all be over ln of x squared. So that's how we get it with quotient rule. If you wanted to do it with the product rule, you would just do y is equal to e to the x times ln of x times e to the -1, that whole thing to the -1. And this is not something you can do the laws of logarithms on, because the logarithm is being raised to the power, not the inside of the logarithm. So that is an important thing to note. But you could just raise that up there and then do that as a product rule. Does this make sense to everybody?
Yep.
Cool. So the derivative of this guy is again going to be a chain rule. So actually kind of a nested chain rule. So this guy would go to, the inside is 2e to the 2z plus 1 over z times 3, is the power here, e to the 2z plus ln of z to the 2 now. So we knock that power down by 1. Does that make sense to everyone? Cool. So suppose the population of a certain collection of rare Brazilian ants is given by P of t is equal to 10 plus, or sorry, t plus 100 ln of t plus 2, where t represents the time in days. Find the rate of change in the population on the second day. So rate of change at a given point, it's asking us for the instantaneous rate of change or the derivative. First thing I have to do is find P of t, and that's going to be a product rule. So the first, so t plus 100 times the derivative of the second, 1 over t plus 2 plus the second times the derivative of the first, but the derivative of the first is just 1. So it ends up being t plus 100 over times 1 over t plus 2 plus ln of t plus 2. So what we would get if we were plug in p prime of 2 to this is 26.866. So, oh, sorry, 886. So that tells us that after 2 days, the population is increasing at about 27 ants per day. So remember this original thing, the unit is in ants, and then when we take the derivative with respect to time, it becomes ants per day. Does that make sense to everybody? Yes, no?
Yeah, wait, just real quick. So basically, it was just derivative, and then you plug in like whatever the number is that it's asking for.
Exactly. So if it's asking you for the rate of change and it only gives you a single point, then it's asking you for the instantaneous rate of change for the derivative, and you just plug it in to the derivative at that point.
Okay, thank you.
No problem. Anything else? If not, then that is all the material that we have for today. Like I said, I will try to get your stuff graded as soon as possible, and it should be done by Thursday. You are free.
Thank you.
Thank you.
You.
Thank you.
Have a good one. Jazziel, I believe you just missed the class.